So, amount of experience. Madam also has an experience not only in structural steel but also in cold form steel. She has helped build a lot of small structures during the earthquake. They have done a lot of small scale structures for using cold form steel for people in that area. She's an expert and she continues to learn a lot of stuff, and she recently submitted her PhD dissertation on a topic of composite steel. So with this one, I would like to ask the madam to present. But before that, I would like to request the HOD to give a few words regarding this industry seminar, which is an attempt made for us to disseminate the knowledge from the industry to students. Professor Surya Prakash.
Yeah, thank you, Mahendra. I would like to welcome all of you for this industry lecture series. I think this is a new initiative we have taken at the institute level, and we are inviting eminent personalities. I think we have one from Mrs. Padmaja, I think in the steel part. And we are really looking forward to have a closer industry academia interaction through this industry lecture series. And civil engineering, as you all know, it is a very much practice oriented. So, I mean, whatever we teach, the theory concepts, it's fine. But then if you also get to know the practical aspects of challenges that design engineers they face in their day-to-day activities, then you will start appreciating whatever is being taught in the classes. So that is the whole idea. And so with that remark, thank you, madam, for your time. And we are really looking forward to this webinar today. Thank you.
Thank you very much, sir. For giving this opportunity, I thank Mr. Madhavan. So I'll go ahead with this presentation now, because we have a very short time. So I would like to brought in a lot of stuff to show your engineers about our projects, describe about our projects. So we'll continue with the presentation, sir.
Yeah, I think that the floor is yours, madam. You can take about 50 minutes, 50 to 60 minutes, and then we will have 15 minutes interaction. Yeah.
Okay, fine. Oh, this is not visible. I should. Be able to view the presentation, sir?
No, madam, we are not able to. Can you go to the rightmost side? Now yes.
Okay.
Put it in full view, ma'am. Put it in that full view. Yes.
Yeah, okay, sir. I think now it's visible.
Yeah, it looks good.
Yeah, okay, sir. Yeah, welcome all faculty and students of Structural Engineering Division, Department of Civil Engineering, IIT Hyderabad. Yeah. So, as a part of industrial lecture series, I'm going to present today about the innovations in steel structures, that is pre-engineered buildings. And in this, I would like to present you an overview of Kirby and PEB design concept, design flexibility in PEB system, evolution of pre-engineered building in India, composite construction, a brief note on that, some of the landmark projects executed by Kirby, then challenges in design and execution of PEB, a case study. I've taken up a case study to present those. An overview of Kirby. Kirby is a part of Aluminium Industries, which is a Kuwait-based multinational and multi-billion-dollar business conglomerate, and Kirby is 100% subsidiary of it. And we have a high-tech standard vision and the values. And about Aluminium Industries, it started in 1932 and is founded by Sir Aluminium, and one of the largest privately owned companies in the Gulf region. And other than Kirby, it has many other business sectors, and it is a worldwide, which has an international presence. And business sectors include automotive, engineering, food and beverages, industrial, consumer, and service. So Kirby comes under the manufacturing sector. And about Kirby, it is established in 1976, a market leader in engineered steel buildings, one of the largest quality PEB solution providers in the world. And we have a manufacturing capacity of 4 lakh tons per annum, 5 factories located in Kuwait, India, UAE, and Vietnam. And we are recognized as one of the largest PEB manufacturers in the world, and over 85,000 landmark buildings executed in more than 40 countries and supported by 300 builders. And you can view the factories here. 5 factories we have, 1 Kuwait, and 2 in India, and Hyderabad and Haridwar, and 1 in UAE, and other is in Vietnam. And this is our corporate office located at Madhapur. It is called the Center of Engineering Excellence. For all the four plants except Vietnam, we have all engineering activities here. Awards and recognitions. Kirby is known as the leader in the PEB. Year by year, by sustainable growth in this business, we achieved so many awards and recognitions. And these are the customer list by sector-wise, by automotive, auto and pharmaceutical, retail, building materials, and others. So these are the clientele, you name them everywhere here. The list of customers are PEB and structural steel, infrastructure and textile, general engineering. And these are the clientele customer list for storage solutions. And regarding sales network, we have present in entire world. And about India, we have sales officers in almost all metropolitan cities, and even interior towns also we have. And I look after north and eastern area. I take care of the total engineering activity in this north and east. Systems and practices. So we have a very expertise engineering, about 250 student engineers, and we have a state-of-the-art facility to code the most obvious design for any kind of complex building in a minimum short time, and using a sophisticated latest softwares. And for design, we use Stagro, MBS, ETABS, in-house softwares like Smartest and Matrix 3D, and for core form sections, CFS. We use Tekla, Xsteel, AutoCAD, BoCAD, RStab, Procon, and ANSYS. And we have an expertise manufacturing facilities, and these are all for automatic roll forming machine for secondary members, and machine roll forming machinery, and the multi-torque cutting machines for build-up, and other build-up line fabrication, and short blasting for surface finishing. And these are the quality certifications we have. Expertise like structural steel. For structural steel is high-rise buildings, other power plants, and also those require a material plate thicknesses more than 60 mm and even 100 up to 100 mm. So to cut, we require a most accurate CNC cutting and machinery is required. So we have the all sophisticated machinery here. We have a separate production line for storage solutions, because all these are made of slotted cold form sections, which is suitable for racking and other storage solutions. And we very meticulously do material inspection from time to time for all the basic material as well as the finished product. checks are done at all stages to provide a quality product to the customer. And welding standards we follow as per AWS, and when required by the customer, we can do the welding standard, follow the welding standards as per SAW and other standards also. This is the quality laboratory. We have a very latest machinery for mechanical property testing, destructive and non-destructive, and welding ultrasonic tests and paint spray test. And these are all the other than the regular quality checks. If customer is required for any special checks, we do all this. And safety procedures. Safety procedures are very much important to maintain, to achieve and maintain zero accidents as our goal. So at every stage in production, factory, as well as at every site, we follow these norms. And moreover, we follow the lead requirements for maintaining, keeping product as a green building. So there, because steel is recyclable and it can be reinstalled at wherever location we require, and no welding fabrication at site. We see that it's not there to avoid save the energy. The other products are other than PEB. Kirby also does the structural steel as well as door solutions. The Kirby PEB applications are various, like any building can be done with PEB concept. So as an example, here are the sector is divided as industrial buildings, warehouses, offices, showroom, aircraft hangars, metro stations, and other agricultural buildings, auditoriums. Any product, any building can be, any structure can be done with PEB concept. That Kirby has proved that. So Kirby, the highlights are Kirby is the market leader across all regions wherever it operates. Completed over 85,000 buildings globally and over 25,000 buildings in India alone, of 35 million square meters. And the greatest thing is for the success of Kirby is like we attend to customer to the fullest, so that 60% of our business is from new customers. The largest PEB in terms of area, a single project in Chennai, Renault Nissan, is 3 lakh square meters. So this is the world largest PEB. So that's done by Kirby. So constructed world's largest gearbox manufacturing facility, and constructed world's largest yarn manufacturing facility, and constructed world's largest container glass manufacturing, constructed world's largest facility for Switzerland energy. Kirby is the only big company which could dare or take it as a challenge to lift 500 crane and tested its site for Alstom Hyperforge. Great achievement for Kirby. So partnering with all the top leading companies across various industry segments for setting up their industrial facilities in all the regions. So first PEB company in the world to enter highly complex metro rail, shipyard, power and high-rise segments. So that's how, with all these highlights, Kirby has put as leader in PEB in the world. So other than regular applications, we also have taken up special projects like multi-story buildings with composite construction. This building Phoenix is in Gachibowli area, and this is done. All the columns are made with composite columns. Flyover bridge in Delhi, which is done for faster arrival. We have taken up this, and each girder weighed around 3,000 tons. This is infrastructure, other TG buildings. This is the G plus 13 floor building in Jammu and Kashmir, a residential complex. So that's a big challenge to be taken up by Kirby. And heavy structures like in Mumbai, G plus 12 floor, with heavy loads in all floors. So these are all done with PEB concept. This is the product range of storage solutions are the racking systems, weight racking systems which are installed inside a warehouse for storing their material to save the storage space. So this is all about Kirby. Then regular PV design concept is explained here now. It's a typical pre-engineered building system. It shows a PV building. They're having a width and length. And this building has a roof, has side walls, and these are end walls. And it basically contains the main frame along the width direction, spaced at a regular interval, and it is called spacing. And the secondary framing system that was arranged on the roof, connecting all the frames or the purlins, and connecting all the columns on the sides and ends are called the side wall and end wall girds, and a bracing system which will resist the longitudinal forces, longitudinal weight forces, and the longitudinal forces are transferred from roof bracing to the wall bracing and to the foundation. Weight forces are transferred through the rigid frame to the foundation to the anchor bolts. Whether tight which the sheeting, the roof sheeting and wall sheeting and wall sheeting, the profile, the metal sheet, which helps in, it will help like a weather tight envelope. And when it comes to load transfer, the sheet in turn will first take the load and you transfer the load to the secondaries, and through secondaries it will get transferred to the primary members, primary frames, and through primary from primary members to the foundation. That's the basic arrangement and concept of a pre-engineered building. And here in the picture you can see the columns and the rafters are tapered, they are not straight. That gives an advantage of reducing the steel. The concept of frame optimization concept I will discuss in later slides. And it shows a typical arrangement of a crane beam, fixing of a crane beam column. And also in this you can see you have a lean-to structure attached to the main building. So PV has an advantage of expanding the building on any direction, or add on the add-on buildings like lean-to canopies and future expansion as a multi-span. All this is possible, easily possible for design and execution. And as I told, that PV design concept, exterior cladding will act as a weather-tight envelope, and it transfers the structural load to the wind and lighters. Because these structures are lighter, wind will be the predominant load that will be acting on the structure. So the engineer should be able to calculate the wind forces very precisely on these buildings. So that forces, the deadline and wind forces will transfer to the secondary framing, and they will be transferred to the main frame, and through bracing system, the longitudinal forces will be transferred to the foundations. So due to the systems approach, use of high-strength steel and use of tapered building subsections, which are optimized by the computer design program, and the use of continuous light gauge secondary steel sections, there is an overall reduction in steel weight, cost, and time when compared to conventional steel construction. The codes and materials. There is a huge upgrade on the codes also. Under ASC, American Institute of Steel Construction Manual, and for the primary frame design, and AII for the cold form section design, and MBMA. MBMA is a manual which is all the PV manufacturers in US, they have formed into an association, and in line with the American code ASC, closely working with AESC, they have developed a manual which gives guidelines for the metal buildings. So that helped a lot in initiating on PB buildings into the market, and that was very successful. And same is used here to take the concept PB concept into the market in the very initial stages. So AWS is another code welding. It gives a very elaborate welding standards, and it is universally followed. Then Indian, as the buildings here we construct in India. So for wind load calculations, we adopt IS 835, and seismic loads we adopt in 93. And alternatively, or as an option, when the design is asked very precisely by the customer or USDN standards, we follow IS 800 2007. And one more thing is the strength of material. The strength and grades of material, engineer should have a knowledge of this. So these are ASTM standards, American standard of for testing materials. All material like primary, secondary, sheeting, everything we use with a minimum grade of 345 MPa. Grade 50 we call, it is yield strength is 345 MPa, and all bolts and nuts we use high tensile conforming to ASTM 325. So sections used in mainframe. So the optimization of PEB is achieved basically by changing the concept of analysis. In the conventional building, we take a truss, wherein the roof truss is designed separately and the columns are designed separately, and separately. Where here we go with the rigid frames. The rigid frames are there are the various types of rigid frames that are adopted. Rigid frame without any intermediate support. And by adopting this concept, gable portal, we call it as some people will call gable portal. With this, the bending moment will straight away reduce when compared to the simple beam. So that's how straight away we are reducing on the load carrying capacity, load on the structure, and following a pre-plated I section in place of hot rolled section. Which is hot rolled sections, we know that they are available with mild steel, like 250 PA grade, whereas we are using high strength steel, that is 340 PA steel. So directly increasing the strength, we require a reduced section modulus, so that the reduced section for the requirement, for the same requirement. Hence, that's how the optimization is achieved on the primary. And moreover, using a pre-plated I section and providing the pre-plated I section matching with the bending diagram of the frame. So there will cut down, means bending will cut down, so the steel also will be reduced. So I can show the optimization of a typical frame optimization concept is shown here. It's a pin-based rigid frame portal, and it shows the bending diagram 0 at base and the maximum at the haunch, and at the ridge is maximum. And the section shape is also taken into the shape of the bending diagram. That's how we reduce the steel consumption and get the optimization. Frame, and it is also made in the into the sections are selected to suit the bending diagram and to get the utmost optimization. And the secondary members are the cold form sections. It's a great invention on cold sections because they provide the highest strength to weight ratio. So this for the secondary members, for the purlin and guts, we use the Z section. It's a very unique section having a zero symmetry, and it is because the shape can be made continuous rafters by providing a lap. Whereas in conventional all ISMC or ANG sections, they will be designed as simple span beams. So there also with the concept of analysis, we are making a simple to continuous beam and reducing the movement there. And by providing this light gauge sections, reduced but the strength is achieved. So that's called secondary members optimization. And, and one more advantage of coulomb sections is, as per the engineer's choice, any shape can be formed with the cold roll coils. And these are the typical roof panel profile and the wall panel. And there are also color coated or galvanized sheets, zinc and aluminum coated sheets, so to prevent corrosion. And as I told, this optimization of secondary members, you can see these are the rafters over which the purlins are made continuous. It will provide a lap. That is the concept of optimization of secondary members. So in general, the main frames are designed with pinned or fixed frame connections and continuous with the movement connections at all frame slices. And purlins and girts are made continuous for the rafters. And sheeting is also designed as a continuous member supported over the secondary members. And frame beams are simply supported only. There is no change in that. But the only thing is we use high strength steel here to reduce the beam depth. And beam are simply supported, and they can be made. Beam spans are more. They can be made fixed also. And mezzanine columns are usually considered as beam supported members, but as per the requirement, if required, we can make them as fixed also, fixed and base. I just want to show a flexibility of a PE when compared to conventional. The same frame, portal frame analysis. This is the regular PEB section, optimized PEB section, tapered column and rafters. In the same, for the same moments, if you select hot rolled ISMB, like it has to be provided a straight column, you will not get optimization. That's how PEB, like a three-plated I section tapered will have more optimized weight when compared to hot rolled sections. And it's a typical example of just want to show the range of options available in market on annuals and I section, which has a variation in weights. The variation is up to 30%, and whereas here also can observe from 20 to 25% it is there in all the sections, increase in the weight. And when you select a built up, the engineer has plenty of choice in selecting his own sections. The variation is weight variation will not be there at all. So, but provided he has to select the section based on the section classification provided in the code. And one more advantage here is never any pointers are there in PEB. You can hang anywhere, but in the truss pattern, it has to be done only at the nodal locations. In this case also, like any build when compared to conventional to PEB, because of the lesser depths here, you get more headroom here, and here will be lesser. So that to achieve the required headroom, you may have to increase the height of the building. We have various types of columns are also possible. In any type of column, engineers choice based on the in the clearance of the building, you can go with a straight column, tapered inside and tapered outside. And this is called a supermarket column. So up to certain height, if some clearance is required, they can go with the straight, and later they can go with the tapered to get the optimized weights. So this is just I wanted to show how it is comparable with the conventional truss type frame. And on the whole, buildings are pre-engineered as they rely on standard design with standard configurations, with each components of the building system uniquely profiled and pre-engineered to suit each design requirements. And using the sophisticated manufacturing facility, and because all these components are pre-engineered and the total quality is assured by single supplier, so that and hence the responsibility is given to one single source. So the quality will be high when compared to prefabricated, which are done at site. Components supplied by various agencies. So that's how the PV concept has achieved a very great importance in the last 2 decades. So evolution of PV evolution, industry evolution in India. So in 1970, Aluminium Group started building systems in Kuwait, Saudi Arabia. In 1999, it is the plant is started in Hyderabad. In the initial years, we had a very tough time to take the concept into the market because the Indian consultants and customers are not ready to accept a change. So at time we limited only a span to 18 to 24 and a small heights and 1 in 10 slope and smaller capacity cranes. And the first project got launched, and in 2001 the PV concept started getting accepted by the customers and consultants, and we have started seeing more jobs there. And 2005 we started the second plant in Hyderabad. And 2010 we have taken up a PV concept multi-floor buildings. Building we have mezzanine floors and cranes also. So multi-floor G plus 1 or 2 buildings that we started for offices and the units. And 2015 we have done that G plus 13 floor building in Jammu and Kashmir. In 17 we have gone up to high buildings up to G plus 25 floors in India. The largest parameters what we have done till now is like varying spans from 18 to 90 meter free span and base spacing from 8 meters to 13 meters, very flat roofs and height from 9 to 80 meter height, multi-floor buildings, and crane loads 10 tons to 500 tons, and we do the buildings from 36 meters to 270 meters. The Renault building, so it was width-wise is low, but length of the buildings are up to 1300. The building length was 1300 meters, so almost 1.2 kilometers. So we have expanded our work, and we have successfully achieved. We have successfully completed all those projects. Has promoted PV concept for composite structural steel high-rise buildings in 2020. That's what the Trini building done in Gachibowli is done with composite concept. Composite construction. The mezzanine floor is steel mezzanine floor. I just want to explain. And this is how it looks. The main beams are kept on the. These are the main beams, and these are secondary beams which are called joist beams, and over which the deck sheet laid. And on that, the nominal reinforcement should be provided, and over that, concrete will be poured. So this is the regular arrangement of a typical steel mezzanine floor. So in this composite, to make it design the joist as composite. As of now, we are doing the joist alone as the composite. So shear studs are connected. So this is a profile deck sheet over which reinforcement is provided and concrete will be laid. And this will, as it is, this will reduce, this will speed up the work. And while doing the concrete casting at the top, people can work below, so it will not have any formwork disturbance there. So that's how it will be very faster work. Composite floors, shear studs are welded to the joist, and that will the deck sheet is also taken as the part of steel in the. So that's how the composite action comes, and the TV composite. And without deck sheet also, with shear case that we have some Indian codes for that. So some people will do that, and but with deck sheet, this we do that. So that's how we do the mezzanine floors with composite action. So this will further optimize the structure. And columns, when it comes to columns, the various types of columns other than a regular I section or tube section. And this is a box column made up of 4 plates. Bigger columns we did for few projects, and 4 plates are welded on the corners to achieve the required size. And this is a star column, wherein the framing action is required in directions. We adopt this type of column also. Composite columns. Composite columns are section embedded in the concrete is a big reinforcement, and same I section embedded in the concrete column, heavy reinforcement, and this is a tube column with the concrete filled column, concrete tube, and this is a concrete tube without any internal reinforcement. So this concept has gained a lot of importance because of this concept, the size of the column will get reduced when compared to regular column, so that the floor space will be improved. And because these can be the tube columns can be manufactured directly in the plant, and it will be supplied and executed at site, and only it will be poured at site. So that will be a faster construction. It gives more floor space. So that's advice there. So that's why it's the latest concept people are calling for high buildings. It's executed by Kirby. So I'll quickly show. There are many actually. Because of the time constraint, I'm showing very few pictures. This is upper tiles. And this is what I'm talking about, the Renault Nissan, the largest PE in the world. So it's a 1.3 kilometer length. Pictures are picked because to show different types of pictures to you. So for aesthetics, you see, you cannot believe that it's a steel building. So any type of architectural features can be added to this DB. And this is a this is a substation near the substation structure. On this building, PV building, the towers are executed on which the cables, the ground wire and the power cables are connected. So that's how it carries a special load and special load combinations. So we could take it as a challenge to do that, and we could do it successfully. Motors, Ludhiana beverages, and fine New Zealand commercial. You see the shape of the building. So any shape as required can be done with the concept. And various projects with different elevations. And these are also common. These are pharmaceutical buildings: Ready Labs, Cipla, Flamingo, and other factory buildings. You can see this architectural feature. It is everything is possible with PV because there are various types of flashings and curvature in the beam and secondary members and primary members. It's possible to do this. And these are the structural steel, like conveyor structures and pipe support structures are done for JSW and Meenakshi Energy. It consumes huge steel. So all this is done using PV concept. And this coal handling shed, it is to cover the conveyors will be there and to clearance. And to optimize the frame, we have made a segmented rafter. So aesthetically also it's good and serves the purpose, and it's a cold storage building. Process plants, and in the entire building, a small part of the building is taken as a tower to cover the process equipment in the building, inside the building. And this is the racking arrangements inside the building, where mezzanines are there, which racking is about to be installed. So inside view of a big warehouse building. And other than the regular buildings, we are proud to say that we have done all the metro frames. I mean, it has huge different shape of curvature for athletics. And this is the Taylor Metro we did in 2002 itself. And it is totally designed the PV concept with high standard fabrication, cutting, everything which was done during that time only. And L&T Metro Hyderabad and Bangalore Metro and L&T Metro Stabbing Yard Hyderabad. So shipyards, each requirement in any building, actually each type of usage have a different requirements. So engineer who is designing should have a total concept of the usage of the building. Without missing, the engineer can design all the required. You can design for all the required loads and clearances and strength-wise, or all accessories he can suggest to the customer. So that will give an added value to the project. So that's how by taking so much care of the customer, so we will be so successful in the market and leaders in PV. So these buildings will have multi-span structures with more heights and different level heights and heavy capacity cranes and glazed columns. All this will be there. So these are the Pipao shipyard and Garden Beach shipbuilders and engineers racing hall. This is in Tamil Nadu. And these are the power plants. Power plants, the TG building, first time Kirby has taken up a challenge to do a tower TG building using the concept. So these are Meenakshi Energy, and these are the various pipe rack structures. We are done at Meenakshi Energy in near Chennai. And aircraft hangars. So we see most of the airports you can find hangar structures done there. And even we have taken up these doors also, and we have tested in our plant door shutters. So we could be very successful in this area also. And auditoriums and convention centers. So this Hyderabad high-tech building also designed by others, but we have taken up the fabrication and supply. And IMTMA Bangalore, the two projects we have done. And these are the shopping centers. The Athlone near our airport, shopping complexes, shopping centers. Rooms. And thus each requirement will have a different requirement. Each application will have a different requirement, and engineer should thoroughly should have the focus on those requirements to be successful. This is one shopping mall in Noida. This is taken up as a structural steel project, and these are the recent projects. So this is what Carlos data center in Mumbai, and this is Vellapalli Brothers in Kerala. GPS 17 floors has a different aesthetics given and different look is given to this, and very successfully we could complete this. And this is one the next build GPS 9 in Chiboli. And this is GPS 13 floor where we are done in Jammu Kashmir residential complex. And this is one very tiny project, but 5 buildings constructed in the heart of Mumbai. We are very busy area and the space is very constrained. We could construct these 5 buildings in one premises for this rehabilitation, like a slum rehabilitation building. Many awards for this project. So, and this is storage solutions, inside view of storage solutions, some pictures of tires with the racking. And not only the mega projects and mega structures, small buildings also, like as a social responsibility. When the Bhuj earthquake has come, we have instantly done this Recently done this cold form buildings, and within a month we could erect the site offices, and in an entire village is constructed using the this concept. Total cold form buildings. These are total cold form light gauge steel. In light gauge steel, we have done that. Centers to give shelter to the orphan children during the disaster, and these are the health centers, and some schools are also connected with this concept. And later also we did many site office projects. And some challenges in an execution of PBA case study. I have taken up a case study because time is less, so only taking the project. This had all types of challenges like design, execution, and transport of the material to the site. By 18-meter height building, or 3-floor RCC building. So earlier that project was started. It was a valley in Sikkim. There were undulations in the ground. So they have constructed already some 3 floors of RCC slabs already, and later they felt difficulty in continuing with RCC, and they have come to us for continuing the project to further flow in the steel. So at that time, so there is a constraint on the column depths and sizes, wherein our column has to fit in exactly over it, and providing with anchor bolts. And that was one constraint. So column depths and all, and column spacings, everything. And so large uneven column spacings and heavy floor loads were there on that, and 2 more levels of mezzanines were there, and over which a pitched roof having 3 hanging roofs, all piles and ducts were hanging from the roof, and walkable false ceilings. And column sizes restricted to match the existing RCC columns. Wall bracing not allowed because of some access of some pipes were there from other sides. Expansion joints in both length and width, because this is in zone 5. In seismic zone 5, we had to provide the expansion joint in both directions to suit the expansion joints below the RCC structure, So that's how we had to give or take all that. And challenges in material transport, maximum length of 7 meters. The roads from Siliguri to that site was very narrow and a single road, mud road, and transporting the material to the site was very, very challenging to us. And even it was a very rainy season, and we had to approach the local authorities to form a road at the earliest time. And like that, we have taken up and we gave the proper solution to the customer, by which customer was very much satisfied. And and one more thing, to erect the structure, it's a 100 by 100 square structure. They didn't allow the cranes inside to erect the structure. So we had to install the boom cranes on outside. To handle the thing. And one more thing, they wanted the requirement, they were in a hurry for the production. So they wanted the supplies by floor. So that is another challenging. So sequential supplies. So in supply of material also has to be done by floor. We cannot supply the purlins first, whichever is done first cannot be transported in the first stage. So like stage by stage, floor by floor, what are the material required, we have to do it and transport it in and making it a maximum length of 7 meters. So these are all types of challenges were there. And erection challenge, no crane is allowed within the building. Challenge in project schedule. So project schedule was also given 6 months time to complete the entire structure. So that's why we take up all the challenges. We were very, very successful, and we could complete the project within time. So that's the capacity of Kirby, and the employees, the teamwork is great, and we accept to do all these challenges. That's how we have become the world's largest PB supplier, manufacturer and supplier. So this is a sequential erection of, just want to show an interesting slides to engineers. This is a sequence, this is an order of execution of the project that happened. So initially few columns are erected, second stage of columns, erection stage. You can see that tower cranes installed on outside the building, on either side of the building, and so this tower, this arm will take care of 180 degrees reach, and the other arm will take care 180 degrees from the other side installation. And this is the next level of installing the floor by floor. The first floor is executed, then the second, and while casting the concrete here, the second floor beams were erected, then the roof rafters, and this had an added staircase structures and new structures. Those are also done simultaneously, and then the rafters are executed, and the remaining structure is completed in the same manner. And later sheeting, and over which the turbo vents. And this is the real picture of the project after during erection project. So the total consumption of steel was 4,000 tons, and we're very proud to say that we have done a very successful project. So, and this is it's all about this project, and this is a 500-ton crane I was telling for Alstom turbine manufacturing unit. So Kirby is the only PV manufacturer who could take up this challenge and do successfully this lifting of the 500 tons. So the testing of that it's also done. Lifting 500 ton from the lifting test is done at site. And one more thing, this is your nearby to your college, this Geeta's auditorium. We have supplied a single beam without any splice for their auditorium. So like that, all types of challenges you have taken. Thank you. Thanks for giving me this opportunity.
Thank you, madam, for the nice and interesting lecture. I would now request my colleagues, Surya Prakash and Anil, to ask any questions regarding, and then we can open the.
Yeah, I think a nice presentation, madam. I just have one quick question. These temperature effects will be there, right? When you go for long span steel structure, right? How do you account for the expansion and what the additional loads that will come from there? That is one thing that I just wanted to, if we can highlight. And but otherwise, I think a lot of case studies. I think of course, we're all used to concrete buildings in India. I think steel is picking up, and I think we're all doing well. So just this one question, I thought I'll just take your feedback from.
Yeah, future expansion, when it initially given, like any expansions required on side walls or end walls and vertically also, it should be mentioned in the initial stage. So when it is told, then we will design the structure for present scope as well as future scope. So accordingly, we will design the building and provide required connection plates and bolts to accommodate the future structure over there. That's how that expansion is possible in any direction.
Yeah. No, I was asking about, the temperature effects, the secondary stresses, whatever that are developing, right? Especially, at the points, how do you account for them?
Yeah, temperature stresses, whether length and width of the building or within the maximum limit of the temperature expansion joint, like suppose American standards, along width they will say around 120 meters and along length 50 meters. So if it is the building length and width are exceeding those, Then we'll take up an expansion joint with slotted holes.
Okay.
Then-
Right.
Or-
So I think usually in concrete buildings, we provide about, you're right, 40 meters, that's about 120 feet. But I think for steel, I think probably you do it at longer length.
As per IS, it is longer. When without cranes, we can go up to 230 meters and the length direction, and along when the cranes are there, it restricts to 180 meters.
I see.
So that's how we do it. Yeah, sometimes we if it is slightly more than the expansion joint limit, then we'll design for temperature stresses, and we look for an optimized design.
So yeah, basically that means, you explicitly have to account for expansion joint in your design. All right. Thank you, madam.
Yeah. Thank you.
Dr. Anil?
Hi. Thank you very much for a very detailed and a nice summary of different types of PEB construction techniques that you have employed. I'm Dr. Anil Agarwal. I also work in the area of steel concrete composites, and as well as our primary focus area where the research is focused is more on the behavior of structures in fire conditions. So steel and steel concrete composites become susceptible to those conditions. That's why I have particular interest in steel structures too. I have a couple of questions. If Dr. Madhavan allows me, I can probably
Go ahead.
ask 2 questions. First question is for PEB construction, you probably have to cut the web and the flanges from a steel plate. So what kind of tools do you apply to maximize the utilization of that plate area to avoid the wastage? Is there any automated tool that you use, or like how do you minimize the wastage?
Yeah, we have specific tools. As I showed in the machinery, we have the cutting and drilling machineries there. And we have basically for PEB, that's a welding machine, Polyurethane welding machine. That's the automatic welding machine will be there, which will weld the 3-plated I section. And for cutting, your question is, am I correctly answering you?
No, I was asking, how do you maximize the utilization of a plate? So you cut the webs and flanges, and how do you make sure that when you are cutting these plates, you are utilizing the plate to the maximum extent?
Yeah, that's there. Because we have our objectives for each and every department, like as the PNC department, they have an objective to reduce the wastage. So accordingly, they'll plan the sizes and lengths, and based on the requirement, they will very precisely plan, and they will achieve their objectives.
So most of this planning is manual, is it? Is it done manually? Most of this planning of how to.
No, we have for cutting we have machinery, but they have a software also, I believe. So we don't go into that angle designs.
Okay.
So they have their objectives and they'll achieve their objective in reducing the wastage there.
Okay. Yeah. Another query I have with respect to this PEB construction, when you have the girders, Indian code IS 800 has a very specific requirement for plate girders, where it says that if you weld both sides of the web to the flange, then you can reduce the slenderness requirement for the web